Now we're going to talk about statistical summaries of numeric data with median, mode, and interquartile range. The median is less likely to be influenced by extreme values than the mean, and its measure of variability, the interquartile range or IQR, is also less likely to be influenced by extreme values than the standard deviation. Therefore, the median and IQR are called robust statistics. And when you do something like a box and whiskers and you see outliers, then you want to consider whether you might want to use median and IQR instead. The median is the middle value in an ordered set from lowest to highest. Half of the values are lower than the median and half are higher than the median. If there's an odd number of data points, it is the middle value then. But if there's an even number of data points, like there is here, it's the average of the two middle values. So you put them in order, like these are, and you count to the middle, and you take the average of the middle too. Here, the median is 161. If we go back and look and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We see that the bottom half is ends at 160 and the top half begins at 162. So the average of those two, we add them up and divide by 2 and we get 161. Or we have R do it for us. The base command in R is median, so median of the variable. Or if you want to pipe it, again, using the rates database data frame, you pipe into summarize and then median, and then the rates are room underscore rate. So either one of those will get you the median. We see this in use a lot in things like income. This is US Census data from 1980 to 2008, and typically it gives us income in medians because there are some very high outliers on that that would skew the mean quite a bit. So typically we use medians for income. The appropriate measure of dispersion to go with the median is called the interquartile range, or IQR. The range can also be helpful just to get a quick look, but the range is sensitive to outliers on the high or the low end, so it is not sufficient at all. As an analogy, standard deviation is to mean as IQR is to median. So how do we get that? Let's go back to our large sample of 20 room rates. The IQR is the difference between the 75th and the 25th percentile, and so it is somewhat analogous to the standard deviation. Notice that means it describes the middle 50% of the data. A percentile is a point below which a certain percent of the data shows up. So the 90th percentile means 90% of the data lies below that value. The 5th percentile means 5% lies below that value. We often talk about quartiles, which divide the data into fourths. Technically the 0th is where you start, but then we look at the 25th, the 50th, the 75th, and then the 100th accumulates all of the data. If you want to just get all the quartiles, then you can use in R the quantile function. Say quantile and then the variable, and it will give you all of these. If you want a specific percentile, then you say quantile, variable, and then you put the percentile in decimal form. So if you want the 99th percentile, you say quantile, then variable, then 0.99. You can also get the 50th percentile doing it this way, but you can also just use the median command. So quantile x 0.50 is equivalent to median x. Okay, those are the same thing. So the quartiles for the hotel rate data We want the 25th, 50th, 75th, and 100th. And we can do those in a couple of ways. One way is to say quantile, and then instead of piping, say rates, the data frame, $sign, and then the variable, room rate. Okay. Now we already know that the 50th, the second quartile, is 161. We've already got that. But let's have R give us the rest. So if we do that command, this is what we get. And notice in our table for quartiles, we start with the 25th percentile, and that is 137.75. Then there's our 161. Then we have 168.5, and then 245, which is the highest value, which is New York, which in this set I have resorted so that New York is at the bottom, so that it kind of goes more in order of how the quartiles go from lowest to highest. So the variability measure is the interquartile range, which is the third minus the first quartile. Now, technically, we could do this by hand, so we could say 168. Let me get a pen. So we could say over here, somewhere here. There we go. 168.5 minus 137.75. So if you're doing it by hand, that's how you would calculate it. But we also have a special R command to do that as well. Notice that this one is in capitals. A lot of times they're in lowercase, but IQR is in capitals. So the command would be IQR and then rates $sign room rate. Or you could pipe into this if you want. So if we do that, we get 30.75. And remember, this is kind of analogous to the standard deviation, so you might want to think back and remember that for the entire sample, the standard deviation is 30.94, and which is not that far from the IQR in this case. There was one outlier that's influencing it. It was on the high end, so that's also making the standard deviation larger because there's an outlier. But that did not influence the IQR. Sometimes you will hear people talk about a 5-number summary. That is the minimum, or the 0th quartile, the first quartile, the median, the third quartile, the 75th percent, and the maximum. So that's a 5-number summary. And then remember we looked at box plots quickly before. Those are the visual summary using this data. So here's how a box plot is constructed. The median is a line in the box. It's a little bit faint, but you can see it here. That X, by the way, is the mean. You can put that in your box plots if you want to compare mean and median. But what you get all the time is this line. The outline of the box is the IQR. So this is the low, this is the 25th percentile, and this is the 75th. And this box describes the middle 50%. The minimum is the minimum value, and the maximum is, in this case, an adjusted, and so this is adjusted to add 1.5 times the IQR. Let me see if I can get over there. So this is the 75th plus 1.5 times the IQR, and anything that's beyond that, either on the high or the low end, if there was anything down on the low end here, there's not, but if there was, would be considered an outlier. One more thing that we use to describe central tendency is mode. This is the value that occurs most frequently, and it's often more useful with categorical than numerical data. Notice here the mode is 167 because that occurs twice over here for New Orleans and San Francisco. That's just not really very interesting. But if we go back to our ideal community data, the mode of this data is town, right? It occurs the most frequently of all these four categories. And that is interesting. Now, if you're trying to get a mean or median of this, you could not do that because this is not numeric data. So the only way that you might describe central tendency for this categorical is with mode.